Hey guys, today I'm going to talk about how to integrate this trigonometry expression, sine to the cube ax times cosine to the fourth of ax dx. So whenever we see this kind of problem, we always want to try to see if we can spot any chain rule, and actually this is one of these questions. So we notice that the sine to the 3, so we notice this sine to the third power can be rewritten as sine square ax cosine fourth ay times sine ax. We are actually getting ready for the chain rule because we always know that if we differentiate the cosine, we're going to get the sine, and kind of vice versa. So what we do next is that we turn this sine into a cosine using trig identity. Sine square plus cosine square equal to 1. Therefore, we can rewrite it as follows. Next, let's distribute it. So at this point, the chain rule should be pretty clear, because if we differentiate the cosine to the fourth ax, basically we know that the derivative of cosine ax is minus a sine ax. So we are going to rewrite it as follows: minus a sine ax minus 1 over a times cosine to the fourth ax dx. You can see that the minus will cancel out, the a will cancel with the 1 over a, so this is still the same expression as above. And for the second expression, we are going to have something similar. Just going to write it down. Minus sine ax cosine 6 ax dx. Okay. So now we are ready to apply the chain rule directly, which is we just apply the power rule on this cosine. So we're going to raise it by 1 power, and this term gets absorbed. So we're going to have the 1 over 5 in front, and then we're going to keep the 1 over a minus in front, plus keep the 1 over a, and this term similarly it's absorbed when the chain rule happens. So the 6 becomes a 7, you get a 1 over 7 cosine of ax. So I'll put the parenthesis here to be more explicit, plus c. So there you go, that's the answer. We can see that we need to pay attention to the odd and even powers of sine and cosine. If we should be able to isolate a sine or a cosine by itself, which will serve as the term to be absorbed when you apply the power rule on the high power terms of the sines or cosine.